Hi guys, welcome back to Max Electronics, and in today's video we will be building a project for a smart home, in fact for a smart cinema. So what it is I will tell you after I explain a few things. Start with a schematic. So very simple schematic. It involves ESP12F. It's got the voltage supply with the USB. It's got the CH340C USB to FTDI converter. Then support components, it's got MAX 3232 and DB9 port. So very simple. So that's a schematic. And now let's hear a quick word from our sponsor who brought us this amazing PCBs. This video is sponsored by PCBWay. PCBWay is the leading manufacturer of high-quality multi-layer circuit boards with unbeatable prices. Simply upload the zip file with your project directly to the website, select your preferences, preview your board, select the postage and get an instant quote. Now you're just one click away from getting your project completed. PCBWay also offers a range of services such as PCB assembly, CNC milling, 3D printing, sheet metal fabrication and injection molding. Your project will be manufactured by highly trained professionals with a state-of-the-art equipment and delivered to you in no time with safely packed and vacuum-sealed packaging. Prototype the easy way with PCBWay. Quality, integrity, reliability. Here is the PCB that was sponsored by PCBWay. Great quality. It's a tiny little thing. It goes inside this plug, which usually you can buy on AliExpress, on eBay. It's just a what would you call breakout plug for DB9. So usually you get those with which way does it go? With a breakout board and a screw terminals here, so you can connect your devices, I guess, easy way without any soldering. So we're using that because that would be an enclosure for it. We've got our DB9 port. It's a female because it's going to go into the things like projector or your TV, say. So the purpose of this device is to connect your smart home to your projector, for example. So some projectors may be smart and they're super expensive, but the one that I have Optima HD33. It's a 3D projector. This way, most of the projectors and devices like this, even some home amps, have COM port for control. And if you open the manual, somewhere around the back of the manual, you'll find RS-232 commands to control the unit. So if you plug your unit into the computer and open something like terminal or termite that I use and send that command, the unit will read it as a remote controlled command. And what we're doing here, we're using a smart home app that controls, usually, I'm still deciding on the app yet, that usually controls your lights, you know, that compatible with, say, Google Home. When you say, hey, or I shouldn't have said that, it's probably triggered yours, your Google's, but so when you say words like that and say turn the light on, it turns the light on. So in this case we're going to be turning the projector on. So that's the purpose of this device. It also has two options for the power, because it does require power. So the first option is you can have the USB port here on those pins. You can see the shield ground, data plus, minus and 5 volts, and you can have the USB coming out of the back of the plug. And then you can plug it into your projector and plug it into USB port or just power port, and it'll supply power and connect to your Wi-Fi. The other option for USB is you plug it to your computer to program it, to change your, firmware or something like that. So it is data USB, not just power. And a third option that I'm going to be using, I will not be using those pins, but I did design it with those pins just in case someone needs them. I will be supplying power through pin 9, I believe it is. Yeah, pin 9, the last pin, which is a ring on COM port. That's a 5 volt supply. There is a diode protection, so if you plug it into USB and supply power through DB9, it is absolutely fine. They're not gonna feed each other. They're all diode protected. So this way, I can have the unit without the USB, just plug by itself, plug it into the projector, I will change. My projector does not have power on pin 5, but I will open it up and I will supply it, and this way I'll just have that plug hanging over the back of it, and that will be a smart projector, and I can say, hey, certain, and then turn the projector on, and it'll turn the projector on, or turn it off, and it'll turn it off. It doesn't require many components, as you saw in the schematic. That's pretty much all there is to it. So we've got our ESP12F, we've got the DB9 plug, we've got 2 diodes, I believe this is the RS-3232, which is a converter from TTL to RS-232. We've got voltage regulator, we've got a button which I thought it'd be handy to turn it on and off, this is a SMD button. I don't have any tall ones. You can get buttons that are really tall, you know, up to 2 centimeters or 20 millimeters tall, but I'll just use a plastic stick and glue it on top, and then I'll drill the hole in here, and it'll be just a little button. LED, which is again to use as output. Some projectors or devices can have, once you turn them on, they'll output another RS-232 command saying that it's on, and that's what the LED will be hooked up to, so you know when it's on and off. This is the little CH340, which is the USB to FTDI converter, and a couple of tantalums and filtering capacitors and supporting components. Lots of capacitors. That's for Max 3232. That requires a lot of capacitors. So anyway, that is it. I'm going to start soldering, and that cap fell out from here, and let's see what we get. The soldering is done. I haven't put any through-hole components or the ESP. The reason is because I'm going to put it through the ultrasonic bath. I really didn't like that soldering paste. This is brand new soldering paste that I bought. And it's when you squeeze it, sometimes it's super liquid, almost like water. And sometimes it's just clogging up the nozzle. Not sure. But yeah, not a good solder paste. I should have used my other one, which is quite old, from April 21, but it's still good. It's great paste. What is it? XGZ40, and this one is XGZ40. So apparently it's exactly the same solder paste, except this one's crap and this one's good. Alright, so here's the circuit board. It's ready for ultrasonic bath. I'm gonna do that because I had to touch up. As you saw, there's a few that didn't solder well. Again, maybe the solder paste. It does look solid, so it looks alright. So I'm gonna put it through ultrasonic bath, and then we'll come back and put the other components in, like LED, ESP and that doesn't need to be programmed in a programmer, by the way. This will do it for you. So I'll be right back. That's been bathed in ultrasonic bath, so it's nice and clean. Now I'm going to put some through-hole components. So we'll start with a big one, which is the port itself, and let's solder that on. So that's going to be a pretty useful device. I am going to still attach the USB cord to it, just so I can program it. Once it's programmed, I'm going to disconnect it. So the only thing I need it for is just programming it. I could program it on the programmer and then put the chip in, but why do that? This way I can test if everything's working correctly. Alright, let's grab some thick solder so I can drown those large contacts in. There we go. Oh, it's coming out on the other side. That was unexpected. Almost shot. Alright, that's done. And now let's add the LED itself. Where did it go? Oh, there it is. And the negative is this way. Solder one pin and then align it. That's actually pretty good. And what we've got the chip itself. I'm going to do it by hand. I'm not going to use the solder paste. I didn't like it. It's a bit funny and dodgy, so we'll just do it by hand. So let's start with the reset pin and then we'll go all the way around. If you notice why there's some pins missing on the board, like you can see there's only a few of them and some of them are completely gone. The reason for that is I always do this with different chips, and on the other side you may have noticed it too. If the pin is not used and it's not structural, so like say if it's not a corner pin, I will usually get rid of it if I'm not using it and there is no purpose for me to use it at all. I will get rid of it because otherwise it seems to be a waste of space just to have a pad on a circuit board, and not having that pad there gives me more room to track when I do tracking, you know, put the tracks through. It gives me more room to move around. If there is a pad there, you have to go around the pad, and you can't really go through the pad because that may still, even if you not solder it, it'll still may short circuit things, and I don't want that to happen. So we've got a few more contacts. And that's it. The board is ready. Now let's see how well it fits. This one, I bought those, I've got another one somewhere. Where is it? Enclosures. This one's a slightly different. If you notice here, that notch on the side, I had to file it. There was a notch originally, but it was a normal straight in notch, you know, like a slit kind of thing. And to get that 45-degree angle, I had to get a file, and luckily I didn't put any tracks through there, so I had to file it off because they've got a little file thing here, as you can see, which is odd. And the board is a bit longer, as you can see, it goes over the top. I designed it for a slightly different plug, which looks exactly the same externally. Oh, it fits well. Yep, it fits well. And even with that on there, still going to close. I'll have to drill a hole for the LED. That's still going to work well. The problem is that the other board, not the board, the enclosure, let me find it. Oh, there it is. It's one of my other projects. And the thing is, I didn't use that because I've engraved it already. It's a Bluetooth module. So if I take that out, that was like a rat nest made. This is same size, as you can see. They are pretty much identically looking. Everything is identical, but inside those things are a bit closer to the end, and there's a notch there, if you can see it. So if I fit that board here, it sits here ideally perfect. Do you see that? So, and this one, it's sitting on top of those things. I could file them down halfway. I don't think that'll affect anything. Yeah, I'll file them down. But I think the board's going to fit here anyway. It doesn't matter. It may be slightly on the angle when it's plugged in. Yeah, I'll cut them with a Stanley blade. I'll just slice that bit off, and that should fit. So, now let me just get a cable so I can attach the temporary USB cable to here. I've added a USB cable, and I am about to glue a little, what I've decided is just a nylon screw that I'm going to glue on top of the button, just like that, and that will protrude, so I'll show you out the other side, and it'll be perfect for the button. There it is. So you're going to hear it click when you press it, so it's not easily pressable. The LED's there as well, drilled the hole for that. Could have probably done a better job on the drilling, but that plastic it's rubbery, so it doesn't shave clean. It's just, yeah, it's stretchy. Anyway, on this it comes with little attachments to screw into your RS-232. There is the assembled device ready to go. It's not programmed. I've decided that because there is such a big variety of apps that you can use, like Blink and Tuya and tons more with different purposes and different appliances, so you can create your own depending on what you're going to use it for. Maybe you'll use it for your TV, maybe it's for your toaster, I don't know. So this is universal. Therefore, you can just search for those apps, and again, it's like Tuya or Blink. It's all IoT devices, and you can simply plug it in through your USB and program it with Arduino, and it'll be ready to go. You can make the LED do what you like and make a button do what you like. Just a normal serial COM that is operated through the Wi-Fi. So this is it. I hope you enjoyed this video. All the schematics for it is available down below. You can free to download, and again, you can operate it with USB or without it. Use a USB to program it, and then get rid of it and use a pin 9 for the power. Don't forget to like, share and subscribe. You can also support us on Patreon. My name is Max. I will see you next time. Bye.